So if I'm looking at this one, we're talking about motion today. We've talked about like quadratics a lot, and we know a quadratic is a parabola. We can have a normal parabola or we can have it upside down. Well, that models motion of a lot of different things. If I take a ball and I throw it up in the air, it goes up and then it turns and it comes back down. So it follows the path of a quadratic. We're going to look at problems like this, and they switch the variables. We have h and t instead of x and y. What do you think h might stand for? Height. So h is your height. It's like the y. It's just how high did the object go. And what do you think t is? Yeah, your time in seconds most of the time. So x and t are the same. H and y are the same. So if I look at the first one, the soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The height h equals negative 16t squared plus 90t gives the height of the ball after t seconds. All right, all we need from that is our equation. Okay, that's what I'm worried about. So A, find the maximum height. All right, let's think about the graph. So if you go to Desmos, so when you are typing it in, you can't use h and t, you have to use x and y, so that's one of the annoying pieces. So our equation was y equals negative 16, instead of t, I'm going to say x to the second, plus 90x. If you do shift in the number 6, it's got the caret, and that would give you an exponent. All right. Oh, never mind. Got it? All right, did everybody get this equation typed in? This red line represents the path that it's taking. Okay, so if I'm asking you for the highest point, what am I asking you for? The vertex. So on Desmos, it's kind of nice. You can scroll, you can zoom in or out. I need to scroll up until I get my vertex. You can zoom out if you don't want to scroll as long. It is way up there, isn't it? Okay. Here's why Desmos is so nice. I want this point. If you just touch there, it tells you what it is. So all I have to do is scroll until I can see my vertex, and if I touch it, the 2.183, what does that represent? That was like my x, which was my seconds, my time. Then my height is the 126.563. So the question was, the maximum height, that's our highest point, so our highest y value. And what did I say it was?
126.563.
And let's see, it told us, did it give us, we are in feet. So that is my highest point. Now we could have done it other ways, like finding a vertex, but we've practiced that already. Now I'm trying to show you some other resources for if you get to a question on the EOC and you don't know what to do. Use this graph. So part B, how many seconds will it take to reach the ground? If you're on the ground, what is your height? 0. So go back to your graph. I've scrolled, but if you just hit this home button, it will recenter your graph for you. So I can touch these points. This one is 0, 0. That's because I started on the ground. So when did it get back to the ground? 5.625, and we were in seconds.
Is that what you put on one hand?
Yeah, you don't even have to fill those in if you don't want to, but yes, those are the answers. Okay. All right, are we okay with those two? Let's take a look at the next one. An apple is launched directly upward at 64 feet per second from an 80-foot tall platform. The equation is this. So all we care about is the equation. The rest of it is just extra. It's how they got their equation. So if I'm asking you to find the maximum height, what am I asking you to find? The vertex. So you have to go type it in. Instead of h and t, though, we have to use x and y. So we'll say y equals negative 16 x to the second plus 64x plus 80. And then what do I have to find? The highest point. So you might need to zoom out or kind of scroll up for a while. It can be a little annoying, but we'll get there. So this point, if you just click on it, it tells us it was at 144. So the 2 is my seconds. My height is the 144 feet. So my maximum height is 144 feet. Did everyone get that to work? And so then, if it hits the ground, what's our height? Yeah, we're looking at when the height is 0, so we have 2. Can you have a negative time? No, so it would be after 5 seconds.
Do I need the calculator or no?
No, just decimal. Let's look at number 4.
Every time you flip the page.
It's a lot of work. All right, a penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by this equation, so that's all I really care about, but it's going to ask me something different. How long would it take the penny to strike a 6-foot tall person? Okay, so if you're standing and you drop the penny, how long is it going to take to hit somebody? So my equation, go here. And that would be our y equals negative 16x to the second plus 1,250. But I'm not looking for my highest point this time, and I'm also not looking for when it hits the ground. What am I trying to find? When it hits a height of what? 6. So go to equation number 2 and say y equals 6. Everybody better be doing this. So I did 2 separate equations because I need to know when it hits the 6. All right, so if I look, not the right thing to do, was it? Okay. It hits 2 different times. This one has a negative x. X is my time. Can time be negative? No. This one is positive. So it takes how long? 8.818 seconds. Let's take a look at this. Number 5 wants to know how long it reaches the ground. If you reach the ground, what's your height? 0. So you're just looking when your height is 0. So did everybody get 5 seconds? All right, number 6. We had negative 16x to the second. Whoa. Plus 20x plus 6. Oh, no, I just typed in number 7, didn't I? Okay, how about this? Okay, and this one wants the maximum height. So what am I asking you to find? The highest point, which is also known as the vertex. And we get 169.391 feet. If I asked you when it hit that point, when was it? 3.156 seconds. All right. Last question. Are we okay on those two? You okay? I just want to look at number 7, and that's my last one. Eva is jumping on a trampoline. Her height at time t can be modeled by this equation. Would she reach a height of 14 feet? So if I type that in, negative 16x to the second plus 20x plus 6. We need our y equals in front. Okay. So when I look at that, will she reach a height of 14 feet? No. If I look, her highest point is at 12.25 seconds. So she would never hit a height of 14. All right, any questions about using Desmos to help us with these graphs? All right.
We just put no.
Yes, that's fine.